Welcome to Chemistry Wide. Today we will see Schrodinger derivation or Schrodinger equation. Schrodinger tells us the Schrodinger equation depends upon the kinetic energy and potential energy. See below, total energy equal kinetic energy plus potential energy. See, total energy E equal Ke plus V. Here total energy equation of the one system means it may be electrons, that is below like. So total energy equal kinetic energy plus potential energy E equal to Ke plus V. According to Schrodinger equation, here we can write total energy with wave function psi below. E psi equal T psi plus V psi. E psi total energy, T psi is the kinetic energy, V psi is the potential energy. Here T kinetic energy operating the wave function psi. Here T is the kinetic energy, it is operating the wave function psi, that is below T psi, and V potential energy operating the wave function psi, that is V psi. So we can say total energy is E psi equal to T psi plus V psi. We know that kinetic energy formula K equal 1 by 2 mv square. Here 1 by 2 or half mv square we can multiply under division by m. So we get m square v square divided by 2m. So kinetic energy Ke equal to half mv square, it gives m square v square divided by 2m. Here m is the momentum P. So we can write, we can rewrite the formula K equal 1 by 2 m square gives m square v square divided by 2m equal p square by 2m. Please note, kinetic energy always does not change in all objects or system, but the potential energy will be changes in all objects or system. Now see, we can move on for potential energy V. The potential energy value for gravitational force, that is V equal to mgh. The potential energy value for simple harmonic oscillator, that is 1 by 2 kh square. The force of attraction value for proton and electron, that value becomes minus 1 divided by 4 pi epsilon naught E square divided by R. Totally we can write below V equal mgx of kx square minus 1 by 4 pi epsilon naught E square by R. Now apply the total energy, that is K equal to E equal to Ke plus V. Here K is the E psi equal to P square psi pi P square psi divided by 2m plus V is the V psi. If we apply this equation at one dimensional x axis, it means x direction. So this equation becomes See below. E psi equal px square divided by 2m psi plus v psi. This equation for x axis are one directional or one dimensional only. This is denoted one direction or one coordination of this system. We know that wave function psi equation we already seen. Psi equal to a h pi h cat, sorry, psi equal to I pi h cat px x minus et. This is only wave function equation. Please check out wave function from this channel. Here A is frequency, P is momentum, X is direction, E is energy, T is time. Now we can differentiate this equation. It is going to calculate kinetic energy and potential energy value. So we can differentiate the respect to time, respect to position and time. If we differentiate with respect to position and time, we can write below like, see below. This is the differentiate, R is the respect, X is the position, T is the time. Now first we are going to differentiate psi, wave function psi, respect with the x axis only or x direction only. That is becomes, see below, dou divided by dou x equal a e power I pi h cat px x minus et. Here I pi h cat px x is becomes, see here. Now if multiply this equation, that is becomes I pi h px and x. If differentiate I pi x px x, that becomes below I pi h cat px. See here. Here a is the constant. If differentiate the ex, that is becomes same ex square. So we can write d ex d into ex equal to ex. Now we can write this equation below, see below. So dou psi dou x equal a power minus I divided by I pi h cat px x minus et h cat px. Here see carefully. Now this whole value equal to psi. This whole value equal to psi. So again we can write simply, see below. Tau psi by tau x equal to psi I divided by h cat px. This is called the first order differentiate of the psi with respect to x. But from above the equation, momentum p is simply p. Now back to again see the main equation. See the main equation we already seen. That is E psi equal to px square divided by 2m psi plus v psi. Here p as at a square, so not simply, so we can write below. See, Now again, if we are going to second order differentiate, that p momentum becomes p square. So p becomes p square below, like dou square psi divided by dou x square. Again, if we can differentiate this equation, that is becomes dou square psi divided by dou x square equal to I divided by h cat px dou psi divided by dou x. Now substitute this equation from above the equation. See below, dou psi divided by dou x equal psi I divided by h cat px plus psi square psi divided by dou x square equal to h pi h cat, sorry, I pi h cat px I divided by h cat px psi. Here 2I, so that is I square, I plus I square. See below, we know that I equal to minus I square equal to minus 1. Sorry, we know that I equal to root minus 1, I square equal to minus 1. This equation, it becomes below like dou square psi divided by dou x square equal to I square pi h cat square px square psi. It becomes, this equation becomes dou square psi divided by dou x square equal to minus px square divided by h cat square psi. This value is second order differentiation of the position. See below. Dou square psi divided by dou x square equal to minus px square divided by h cat square psi. This is the equation for this. Now we are going to differentiate with respect to time. So this is becomes, if we add the time, that is becomes tau psi divided by tau t equal to a e power I divided by h cat p x minus et. Here a is the constant. If differentiate this value with respect to time, that is becomes, see here, ei divided by h cat minus et. Here no need e, so we can remove the e here. So equation becomes tau psi divided by tau t equal to ae power I divided by h cat px x minus et minus ei power, sorry, ei divided by h cat. This is going to ei power h cat. This first order differentiate of respect with the time equation. See, this full value we should take as a psi. Here also we should take as a psi this full value. So we can write below tau psi divided by tau t equal to minus ei divided by h cat psi. This is first order differentiate of psi with respect to t. T is time. See carefully. Already we have second order differentiate of position equation. We already seen. Now we have first order differentiate of psi with respect to time equation. We have now this equation. So now we are going to apply this both equation with the kinetic energy and the potential energy. We will get total energy equation. Note, before apply this both equation, see here, before apply this both equation with the kinetic energy and the potential energy. So now we are going to slightly modify the respect to time equation, that is dou psi divided by dou t equal minus ei divided by h cut psi. This minus, if we going to down, it becomes plus I. This minus is going to below, it is becomes plus I. We know that. Next, so minus I, it gives plus 1 by I. Here tau psi divided by tau t equal to E psi divided by h cut I. Here we need E psi only, so that is E psi equal h cut I dou psi divided by dou t. This is energy equation. We already derived second order momentum equation, that is we already derived. If you want to see from beginning, that is p x square psi equal to minus h cut square dou square psi divided by dou x square. This equation we already have. We know that potential energy and kinetic energy. Now we can write main equation. So we can write it the main equation, that is E psi equal to px square psi divided by 2m plus b psi. Now apply the respect to time first order equation, that is px square psi equal to minus h cut square dou square psi divided by dou x square plus E psi px square psi divided by 2m plus b psi. It becomes, if substitute this both equation, it becomes, see below, h cut I tau psi divided by tau t equal to minus h cut square divided by 2m tau square psi divided by tau x square plus v psi. This is the final equation. See again, from this final equation, h cut I tau psi divided by tau t equal minus h cut square divided by 2m tau square psi divided by tau x square plus v psi. Here this is the total energy, this is the kinetic energy, this is the potential energy. See below, So this part is the total energy, this part is the kinetic energy, this part is the potential energy. Here kinetic energy has a second order differentiation and E total energy as a first order differentiation equation. See below. Note, please note here the second order differentiation with at x coordinate particles only. Here second order differentiation with at x coordinates particles only. It means it only for x direction. It means this equation apply for only x direction. See below. If we take 3D or 3 direction, that is psi equal to x, y, z, t. This is the 3 direction for Schrodinger equation. This is the 2 direction for Schrodinger equation or Schrodinger derivation. So this topic is over. Please subscribe the channel. More topics on the way. Have a nice day. Please share with your friends. We are making more videos from organic, inorganic and quantum chemistry. Have a nice day.